Free energy now.
Imagine a world in which each home has its own power generator that obtains its energy in such a way that no fuel has to be added. Imagine every vehicle being able to run without ever stopping for fuel. Imagine each appliance having its own power source that never has to be recharged. That is the world of the future. Join with us now as we track our progress towards such a world.
Welcome to the show. I'm your host, Sterling Allen. You can join us online at freeenergynow.net, where you can find a list of past guests, download those interviews, and read the stories associated with those shows. We're joined today, January 20th, 2014, by Randall Mills of Blacklight Power in New Jersey. They put out a press release on the 14th of this month saying that they're going to be doing a demonstration on the 28th of their Blacklight Power system, which is capable, once they got everything in place, and in the interview you'll see that he's basically very close to having a full prototype ready to go. It would be capable of 10 megawatts in 1 square foot of space. Crazy power density, and I mean, that's usually you think of the amount of energy in that compact space, but we're talking about the machine itself, and the components could be that small. And he'll explain the components that go into it, the mechanisms involved in going straight from plasma to electricity. We actually did an earlier interview, and I had rebooted my computer last night. I had an issue, and for some reason my Skype recorder didn't turn on, and so we didn't have the recorder turned on. When we had this excellent interview, I asked him the questions, he responded to the questions. And so this is basically take 2, and since I already asked the questions and he had to go to a meeting, so on a short fuse basically got the fire hydrant treatment of all the answers, all the information, great stuff. So I'll be able to pull from my earlier interview as well the notes that I took, just written, to fill in the pieces at pesn.com. Probably put that up today, January 20th, 2014. So here we go with Randy Mills of Blacklight Power.
Yes, Sterling. So we have a new type of power source that uses a solid fuel. It has one of the major components is water, H2O, that we run a very high current through. It converts that water, particularly the hydrogen in the water, to a new state of hydrogen. It's about 200 times more stable than ordinary molecular hydrogen you buy, say from Praxair or Linde or something like that. And that energy is released in extraordinary powerful plasma. The amount of power that we're getting is typically 1 to 10 megawatts of power in a volume that's about 10 to 100 microliters. That's about 10,000th of a liter. So if you take 1,000,000 watts, 10 to 6 divided by 10 to the minus 4, you've got about 10 to the 10 watts of power per liter, which if you took, to give it a comparison, the entire United States grid is about 600 billion watts, and we're in the tens to hundreds of billions of watts per liter. So it doesn't take very much volumetric displacement to get that kind of power that would be comparable to the entire United States electrical grid production in terms of the power that's putting electricity out on the entire U.S. grid. The device has a very, very simple device. Has a 2 electrodes that combine the fuel. We have interdigitating gears that the fuel flows into the gears. The fuel occupies a volume that's a triangular region that's about, just give you, for example, for a 10 megawatt unit, it would have 2 millimeters thickness of fuel. It would have a base in a triangular interdigitating region of about 4 millimeters. It would have a width of about 1 centimeter, which is about under half an inch, and that would be enough fuel to give you about 10 kilojoules of energy. Those gears are rotating at 200 RPMs. They have 60 teeth, and that gives you a burst of power, an impulse of power of about about a millisecond time scale, and that time of rotational speed and that type of fuel loading will give you that burst of power every millisecond, and at 10 kilojoules of energy per pulse, translates into 10 megawatts of power continuously. It makes a very, very powerful supersonic expanding plasma. It goes into a magnetohydrodynamic converter, converts that plasma, extraordinary energetic plasma, directly into electricity, and puts out very, very high conversion efficiencies. We anticipate almost 10 megawatts of electricity. The device has on it also some heat sinking. It has a fuel recapturing regeneration system that takes the fuel, which is unchanged other than water is consumed, rehydrates it, and circulates it back into the system. In addition to that, there's some power controlling systems and a power conditioner and a power source to drive the electrodes. So it's very, very simple, off-the-shelf technology. Magnetohydrodynamic's been around for a very long time, many decades. It's been built up to 600 megawatt scale, and it's a technology that basically has been looking for an application. Same as a laser, was originally a technology, an invention that was in search of an application. Our application is absolutely perfect for it. We have supersonic expanding plasma. We're 10 million times the power density of fire. Magnetohydrodynamic is almost commercially viable in terms of conversion of fire, and at 10 million times the power and characteristics, and having supersonic expanding plasma, it's absolutely ideal. It's going to be extremely small equipment, very cost effective, and in a very, very powerful way of converting our source of power directly into electricity. Response time is extraordinary. It's almost instantaneous, so you don't need the grid. So we envision a power source that's going to be DC electricity, direct current. It will not involve the grid. Everything in your home, heating, lighting, air conditioning, all your consumer electronics, essentially everything in your home, all your appliances, refrigerator, washer, dryer, use DC motors, they use DC electricity. There's tremendous losses in having alternating current for transmission and then converting it back to DC in your home. So we envision a DC home. Similarly for cars, we envision DC cars with electronic commutating motors. The AC motor, it doesn't have the power, doesn't have the speed that DC motor efficiency a DC motor has. Everything's going DC motor. All cars are DC motor right now, the hybrid cars and electric cars like the Volt. The only exception is the Tesla Roadster, and it's really, there doesn't seem to be a clear advantage why that's an AC motor in the first place. So we see electric cars, we see homes, we see businesses, we see factories, everything going DC, and the elimination of the grid. And in terms of cars, I mentioned that tremendous power density. Our source is 1 million times more power dense, that is the power per unit volume, than a Formula One racer. There's nothing on this planet that has a higher volumetric power density that's controllable. The cost factor for this looks like it would be extremely, extremely inexpensive. For example, you want to compare it to coal, about $1,200 a kilowatt, gas $800, solar is very expensive, $2,000 a kilowatt, wind $1,200, but then you have intermittency with those devices, so you have to have backup plants anyhow, and you have problems where they're out in remote areas, you have transmission problems. This is on-site, continuous electricity, continuously controllable on a very, very fast time scale. So it's fast in the grid, so you need no grid backup, and you're looking at about $10 a kilowatt. So there's nothing that can compete with it in terms of capital cost. There's no pollution because it makes a more stable form of hydrogen product. The hydrogen's been characterized extraordinarily well. We have 12 analytical tests that identify this new state of hydrogen in terms of spectroscopy, and we think it's the most ubiquitous substance in the universe. It's the long-sought, we call it, quote-unquote, if you're a scientist, dark matter of the universe. It's what makes up most of the mass of the universe. You can't see it because it's so stable, and it doesn't undergo electronic transitions, doesn't react. But you can see it vibrate, rotate. It's just a more stable form of molecular hydrogen. And if you look at space, since the entire universe that you can see is made out of hydrogen, it makes a lot of sense that the part you can't see, or what they call the dark matter universe, is this more stable state of hydrogen. And we can show that, as I say, by multiple analytical tests, and then also the characteristic spectrum that's emitted when this new state of hydrogen forms. So what we plan to show in our demo on the 28th is I'm going to do an introduction of what this new state of hydrogen is, what the implications are, the ramifications in terms of how it came about using just solving what the electron is electron being real, as we're real and we're comprised of electrons. Electron's a real entity. No one really did the hard work to describe what it is. They just modeled it by statistical mathematics, and you can do any type of modeling you want, and it's basically curve fit. You're always going to get the right answer, but you really can't predict new things, and that's what this theory does. It predicts hydrogen. You have a more stable state using the same laws and same engineering principles their entire modern society is based on. It's very straightforward. You can solve extraordinary intractable problems just using physical laws once you solve what the electron is. And it predicts this energy process, and it's absolutely controllable, and it actually, the new state is absolutely identifiable. So I'm going to talk a little bit about that we have a new energy source on this planet, that the hydrogen fuel being, and the particular hydrogen source being H2O, which covers almost the entire surface of the planet, can serve as the fuel. And that can be converted to this more stable state of hydrogen on a volumetric basis. You're looking at 100 times the energy from water than you would from high-octane gasoline. And the product is non-polluting, completely safe, non-radioactive, non-CO2 producing. Makes this more stable hydrogen you can't keep in the atmosphere. It would vent out of the atmosphere because it's about half the mass of helium on the planet, completely inert as well. And we're gonna show this very, very energetic reaction. Makes this extraordinary plasma in extremely, extremely small volume, millions of watts of power in very, very, very small fractions of a liter that represent billions of watts per liter. The entire power production of a plant equivalent can be in a liter volume. Make it continuous. We just have to flow fuel in, as I said, 200 gears, or excuse me, 200 RPM, 60 teeth per gear, small volume with these interdigitating gears, a space occupying that contains about a fraction of a gram, about 0.5 grams of material. Rotating at 200 RPMs will give us 10 megawatts of power. Very, very easily converted. I'm going to talk about that, system engineering. I'm going to talk about the commercial applications, route to commercialization, and we're going to show the energy balance in the device, and we're going to show the spectrum that identifies this new form of hydrogen that's formed as a product. So the device can use off-the-shelf components. You need a fuel vessel, hopper that flows fuel down into these interdigitating gears, conventional off-the-shelf mechanics. The hubs are heat sinked, and we've got the engineering for that worked out. The plasma flows into a magnetohydrodynamic converter. That's basically magnets and some electrodes. You need a fuel recapturing system, which are a couple augers like they use in the pharmaceutical industry. Goes into a reservoir, again, stainless steel reservoir off the shelf. It's exposed to steam, which is basically produced by heat that's rejected from the gears, from the heat sink from the gears. The fuel is rehydrated, goes back into the fuel hopper and flows back into the system. You need a couple electrodes, power supply, power conditioner, all off-the-shelf technology. It can be built very, very quickly from component parts. We've already ordered a commercial device that will provide electricity to the fuel on a continuous basis. We're building the mechanics and injection system to run that so we can make continuous power in the order of 1 million watts or more. So it's very straightforward, very clean technology, extremely safe, and it doesn't require any additional engineering system development other than integrating existing components and systems.
And one question I didn't ask before, on the whenever you're producing electricity, typically heat is an issue, and dissipating heat, and the amount of energy you're talking about, 10 megawatts in 1 square foot. Do you conceive that heat might become an issue?
We have that heat work engineering we're working on now. We're going to have heat exchangers on the hubs and the gears. The gears have, as I say, 60 teeth on it, turning at 200 RPMs. So that means almost 160 of the time they're not actively undergoing the power ignition and power generation. So they get heat sunked to another gear, and also a heat exchanger. The hub that the gears rotate around is heat exchanged. The supersonic plasma that's expanding into the magnetohydrodynamic chamber That chamber is heat sunk. We can also add heat exchangers, water wall to the reactor vessel that encases the gears that are igniting the fuel, and also encasing the magnetohydrodynamic converter. The power density is extremely high. It's phenomenally easier to extract heat when you have a very, very high temperature gradient, very high concentrated power. If you have power over extraordinary large area with very, very small heat gradients, it's very hard to extract heat, but this is very, very straightforward. And we have engineers working on it, and we do think we can heat sink it. One of the advantages of magnetohydrodynamic, even using fire, which is extremely low power density in a comparison, our power density is 10 million times that of fire. And fire is almost commercially viable magnetohydrodynamic, and they predict magnetohydrodynamic with fire could be as high as 60% conversion efficiency. Our calculations show we can probably get 90% or better because our plasma power is so vastly higher and so vastly denser than fire, which all those go in a formula. It's the squared. It's a squared formula of velocity in terms of conversion efficiency, and power density conversion it all goes to the squared power. So we should have much higher efficiency. So there shouldn't be a lot of waste heat. Most of the plasma power should go to electricity.
And
basically, what a magnetohydrodynamic, so the reader, your listeners know, magnetohydrodynamic is same as a generator. A generator basically has a spinning coil and a magnetic field. Magnetohydrodynamics is just two magnets and two transverse electrodes. So it is a generator. So what's spinning? Rather than a wire spinning to produce a current in the magnetic field, this is the plasma flow itself. Plasma flow is like a current, and the current goes into the magnet in the magnetic field, and the magnetic field separates the positive and negative ions and produces a voltage. So it's same as a generator, but this has no moving parts. And it can be very, very efficient if the plasma, and that is the current, is very high, and that means the plasma has to be moving at very high velocities, and very, very highly ionized, very energetic, and that's what we have. And very high density. So that's ideal, and it could be extremely efficient, so we shouldn't have much heat.
So you're basically going straight to electricity.
That's right. You're basically looking at a huge impulse, enormous power density, and you have positive, negative ions flying out into magnetic field and converting directly to electricity. So it's very fast, can be controlled, essentially instantaneous, so you don't need the grid, and then everything in your home is DC, and you can go DC lighting, DC air conditioning, DC heat, that you use electric heat, and I like electric heat because it's constant. It's not pulsable. The furnace doesn't come on and off and on and off. It's on all the time, and you just set it exactly the way you want it. And you can use as much heat as you want because the power is so phenomenally cheap. You're looking at $10 a kilowatt capital cost, no fuel cost, no pollution, and you can have just tremendous power in a very, very small volume and completely can disconnect from the grid. Instantaneous response and enormous power, much more than a home could ever use for a very, very cheap, compact device.
What about time to commercial product?
Again, all off-the-shelf materials, magnetohydrodynamic, you need magnets, you need chamber, you need electrodes, you got power conditioning system, you got fuel reservoir or hopper, you've got gears, interdigitating gears, so you just need a pair of those, you need motors to drive it, you need drive gear, you need a system to heat sink on the hubs, system heat sink on the MHD converter, and the fuel recirculator, two augers from the you can use typically what they use in pharmaceutical or food industry. So all off-the-shelf components can be built very, very quickly. It's just a matter of getting the parts together and assembling them. As I said, we're going to get a commercial seam welder that produces the type of continuous current we need to ignite the fuel. And we're retrofitting that with gears so we can interdigitate that and control the current and direct that current through the fuel in different impulses at a millisecond time scale. Then we get continuous millions of watts of power coming out in the form of plasma. So it's a very, very straightforward off-the-shelf type of integration project.
Well, very good. I appreciate you, just for the audience, we had this recorded before and I didn't have my recorder turned on, so Randy's generously agreed to repeat what we'd already gone through before. And so you just got the fire hydrant treatment, and it was wonderful. I appreciate
Yeah,
your
I
time.
just had to run to a meeting, so I just wanted to give you a quick fire hydrant. And I'll be around, in the afternoon. We have a meeting, but I'll be very willing to give you a little slower version of that.
Okay.
Anytime you want.
All right. Well, thanks, Randy. I really appreciate it.
Okay, Sterling, take care.
You've been listening to Free Energy Now, brought to you by PES, Pure Energy Systems. You may access past archives and upcoming show info at freeenergynow.net and join us for our daily news at freeenergynews.com. We invite you to see our directory of energy technologies at peswiki.com. That's peswiki.com. PES, the Pure Energy Systems Information Network.
We had this excellent interview. I asked him the questions. He responded to the questions. And so this is basically take two. And since I already asked the questions and he had to go to a meeting, so on a short fuse, basically got the fire hydrant treatment of all the answers, all the information, great stuff. So I'll be able to pull from my earlier interview as well the notes that I took, just written, to fill in the pieces at pesn.com. Probably put that up today, January 20th, 2014. So here we go with Randy Mills of Blacklight Power.
Yes, Sterling. So we have a new type of power.
It would be capable of 10 megawatts in 1 square foot of space. Crazy power density, and I mean, that's usually you think of the amount of energy in that compact space, but we're talking about the machine itself, and the components could be that small. And he'll explain the components that go into it, the mechanisms involved in going straight from plasma to electricity. We actually did an earlier interview, and I had rebooted my computer last night. I had an issue, and for some reason my Skype recorder didn't turn on, and so we didn't have the recorder turned on.
Power source that uses a solid fuel. It has one of the major components is water, H2O, that we run a very high current through. It converts that water, particularly the hydrogen in the water, to a new state of hydrogen. It's about 200 times more stable than ordinary molecular hydrogen you buy, say from Praxair or Linde or something like that. And that energy is released in extraordinary powerful plasma. The amount of power that we're getting is typically 1 to 10 megawatts of power in a volume that's about 10 to 100 microliters. That's about 10,000th of a liter.
Free Energy Now.
Imagine a world in which each home has its own power generator that obtains its energy in such a way that no fuel has to be added. Imagine every vehicle being able to run without ever stopping for fuel. Imagine each appliance having its own power source that never has to be recharged. That is the world of the future. Join with us now as we track our progress towards such a world.
Welcome to the show. I'm your host, Sterling Allen. You can join us online at freeenergynow.net, where you can find a list of past guests, download those interviews, and read the stories associated with those shows. We're joined today, January 20th, 2014, by Randall Mills of Blacklight Power in New Jersey. They put out a press release on the 14th of this month saying that they're going to be doing a demonstration on the 28th of their Blacklight Power system, which is capable, once they got everything in place, and in the interview you'll see that he's basically very close to having a full prototype ready to go.